We require the following items. A CBR mold. The mold is 152 millimeters in diameter and fitted with a detachable perforated base plate, a spacer disc, and an extension collar. A loading machine capable of applying force at a constant rate of 1 millimeter per minute. A penetration piston. Surcharge masses. An LVDT or dial gauge. Mixing trays. A 2.5 kilogram mechanical rammer with a 300 millimeter drop. A soil balance accurate to 1 gram. A straight edge. A drying oven set at 105 degrees Celsius. Moisture tins, and a pre-dried and pulverized soil sample passing the 4.75 millimeter sieve. Lime, at the percentage determined from the lime demand test. For this soil, that is 3% of the dry mass. 0.32% of chem-based solution by weight of dry soil, at a ratio of 2:1 for stabilizer to activator. Estimate the total water remaining to be added and split it in a 7:3 ratio. Use the 70% portion to mix with the stabilizer and the remaining 30% to mix with the activator. We will also need a spray bottle for applying solutions. Appropriate measuring cylinders and syringes. First, add the lime and mix thoroughly. Spray the stabilizer solution and mix well. Then spray the activator solution and mix again thoroughly. Smear and break down any large clumps to create a uniform layer. Place the spacer disc at the bottom of the mold. The sample is compacted in 3 layers, with each layer receiving 55 blows using a standard rammer. After compaction, remove the extension collar and trim the surface flush. Remove the base plate, spacer disc, and extension collar. Seal the sample and mold. Place them in a bucket with a cup of water to maintain a moist environment. And cure for an additional 7 days. Then, remove the sample from the container. Measure and record the mass of the compacted soil sample with the collar to later calculate the compacted dry density. Invert the collar so that the surface which was in contact with the spacer disc is now facing upwards. Take a small portion of the unused soil, place it in a pre-weighed moisture tin, and dry it in the oven at 105 degrees Celsius to determine the moisture content. The CBR test is conducted using a penetration piston mounted to a loading frame. Place a surcharge mass on top of the specimen to simulate field loading. Lower the piston until it contacts the surface and zero the LVDT. Apply the load at a constant rate of 1 millimeter per minute. Record the load readings at penetration intervals of 0.5, 1.0, 1.5, 2.0, 2.5, 3, 4, 5, 7.5, 10, and 12.5 millimeters. Plot the load versus penetration curve and determine the CBR values by dividing the load at 2.5 millimeters by 13.2 kilonewtons and the load at 5.0 millimeters by 19.8 kilonewtons, then multiplying each by 100. The higher of the two values is reported as the CBR. This concludes the procedure for determining the California bearing ratio in accordance with AS 1289.6.1.1.